Okay, I made you as co-host. I think it should be okay, right? In case you are speaking, you are on mute.
I got it.
Okay, sure. Thank you. So let me just close this and so okay. So let's get started. In case the voice is breaking or something of that, just ping me. Just unmute and shout out because I'm not able to see the chat. So what we are going to do today is we are going to talk about Redshift ML, which is one of the a new feature we incorporated in Redshift, and that's quite an interesting feature for people who are into database or data analytics or data warehousing, and they are also looking into machine learning capability within their data warehouse. So I do have this deck which is very small, but I don't want to walk you through this because it would be very boring. What I'll want to spend time on for next 30 minutes or so, we'll try to get through the demo, and I'll share you the GitHub repo. You can play around with that. And also there is a blog. There is a two-part blog. So whatever we are going to discuss now, it's already there. So even if you don't watch this, recorded version, you can just, it's better to go over the blog because it has more information, and you can try out. And if you face any issues, just let us know. We will try to fix that. Okay, so the only thing is, before we get into the demo part and all of this, this feature was in preview since reInvent 2020. Okay, so this is something that we have announced in during the reInvent, and it got the GA just a couple of days back. I guess last week only it got GA. So it's now available for everyone. So I'll show you where is the difference, in this blog, because this blog was written, in March. At that time, it was in review. Okay, in preview. So let me just spend a couple of minutes in this slide, and then we will go back to the console and see all of that in action. Okay, so I'll just put that in presentation mode. Okay, so a few just and blabbering around. We all
Can
know
you
this.
swap the screen if you don't mind?
Oh, okay. I thought that
Sorry for that.
no problem. Is that better now?
Yes,
No?
yes.
Okay, cool. So if you look at it, right, this is just a common thing. Everyone of us knows about this, that we are generating a lot of data as we speak today, right? And with respect to what it was, 5, 10 years back, or even 20 years back, we can't even imagine the era we are in now, right? When we compare, previously, we have IoT devices, sensors, then tablets, phones, etc., etc. We are generating data every passing day. If you just look at your phone today and see what is the used storage in your mobile phone, you will be astonished to see that. Although you do not look into that data, maybe like images that you get from your friends and families in WhatsApp and different other applications, you may not see that, but that is consuming a lot of data, right? So we are living in the world of data. Now when you look at it from analytics standpoint, we have a lot of different challenges. So now we are not talking about machine learning. Okay, so we are just talking about from a data analysis standpoint, like what are the challenges that any data analyst would face in today's world, because we have different types of data coming from different sources, and to make a distributed system like that itself is a huge challenge. All right, so all of these complexity makes it even more harder to implement any analytics use case on top of it, right? So and there are multiple reasons for that. One of the reason is these are very hard problems, and when you have multiple systems and when you do a distributed run a distributed workload, that becomes very slow, and to optimize performance there are a lot of challenges there, right? You can imagine all of this, and on top of it you have the cost and compliance, that you cannot predict anytime during your design phase. So how we can recover this, right? What are the what are the services that we have from AWS which can handle all of that requirement, where you will have your requirement is very simple. You need to analyze all of your data which are coming from different sources. Okay, and you have to do that at scale. So maybe today you have 10 data sources coming from 10 different places, but tomorrow it might be 100. So you should have a system which can able to scale, and it should give you a predictive cost, so that you don't blow up your bills, right? So this is where Amazon Redshift come into picture. So Amazon Redshift is our data warehouse service, and which can scale to petabyte of storage, in terms of capacity, and you can make a cluster of systems, and everything will be seamlessly addressed by Amazon in the backend, or AWS in the backend, right? So and it's pretty cost effective, and it gives you a very good performance in with respect to price point, right? So if you have not worked on Redshift, that's okay. We will go to the hands-on and see how to create a Redshift cluster. But Redshift is our data warehouse service. It's not a database, right? Okay. So there is a significant difference between data warehouse and database. So in brief, data warehouse is a place where you will have a lot of OLAP kind of application, for analytics, not a small IO your workload. If you send a small IO workload, it will not perform that well. Okay, so because that is not how it is architected. So for that we have different databases like SQL, like Aurora, or RDS, and so on and so forth. Okay, so this is for analytics, for when you have data from different sources and you want to do some analysis on that, so that you can take some business decisions. Now, there are different, people who wants to analyze different types of data, like data analyst, data scientist, BI professionals, and they all have different types of, requirement and different types of use cases. So we should have some, idea of how to help all of these different professionals, right? So how we can do so. So this is where machine learning comes into picture, where we can make use of machine learning to do a lot of analysis by ML itself, right? But within the Redshift cluster. So as a Redshift cluster admin, or as a data analyst, right, you may not be aware of all the machine learning, theory or machine learning knowledge, right? But you are aware of SQL, because that is how you will mostly interact with any data warehouse or database. Now, how you can enable an SQL or a database admin to make use of machine learning, so that they don't have to learn Python, they don't have to learn, let's say, R, to do something with machine learning. So how we can do so? And this is where this Redshift ML comes into picture. Okay, so I'm just keeping these all buffer slides, because these are not that important to know, at least for this audience, but these are all business slides. But one of the things that in machine learning we all know that we have is it is pretty complex, right? You prepare your data, you build a model, then you train it, and then you deploy it, right? This is a typical way of any machine learning workflow, right? Now, if you look at it, if you want to do some machine learning activity on your data warehouse, you have to start with preparation, right? So your data should come from your Redshift cluster, and then you have to take that data to, let's say, S3, and then you have to train a model using SageMaker, and then you have to deploy it on SageMaker, and then based on the inference, you have to again send the data back to Redshift cluster, because all of that you are doing is to make use of Redshift as a source, data source, right? So this is very complex, and again, this will require the data admin or database admin to have machine learning expertise, right? So which we don't want, right? And no one would want that. So this is where Redshift ML comes into picture, okay? And how it is out. It is out in a way that you don't have to learn machine learning for this. Okay, so all you have to do is you just have to write SQL queries, and internally, Redshift ML will train a model on SageMaker, and it will give the prediction back and it will store the data back to the Redshift cluster. So you don't have to worry about how Redshift is managing the data internally, because for SageMaker to train a model, you need to have the data in S3, right? So that means from Redshift cluster, someone need to take the data from the cluster to S3 and then tell SageMaker that, hey, now your data is in S3, please go and use that to train a model. And what type of model, what is the problem? All of that you can say via simple SQL query, okay? And then S3 will train a model, and how it will train? It will use the AutoML functionality, which will train lots of different models in the backend, and it will pick the best one. And based on some performance characteristics, that means it will select the best model in terms of accuracy or RMSE, or there are different KPIs we have for performance evaluation for a machine learning model, right? So once that model is picked up, it will send it back to a Redshift, and it will tell Redshift that, hey, this is the function which is actually an endpoint, and you can just do a query using this function, okay? And these things will be I'm very sure you are not able to get any head around this, but once you get into the demo part, I guess things will be very easy, okay? So now I'll just skip this because this is not that important. Now this is an important slide, and after this only we will go to the demo part. Okay, so this is how it works. So what we are doing here is imagine that you have a Redshift cluster which has data of all of your customers, right? That means and that customers, maybe you can pick something like let's say customers of, let's say, Amazon.com. Okay, the retail company. And now, as an analyst, you want to predict, you want to know basically that how many customers will retain their account next month. Okay, what is the likelihood that a person will deactivate their account? So that means you have to use machine learning to predict whether a person will deactivate its account or it will continue its account based on the data that you have. And what are the data that you have? As a retail company, you may have his name, age, then address, how much amount of money that you spend on shopping, so on and so forth, right? So all you have to do is you have to run an SQL query like this, create model, and then you have to give some model name, and then you have to give the input data, right? For machine learning to train, you have to give the input data, right? And this is what the input data would look like. And this input data would come from a select command, right? And this is all SQL. Whatever you see here, it's all SQL, nothing fancy here. You don't have to teach machine learning to any database admin or data analyst, right? So they can always do this, who are working with SQL. But the new semantics here is this create model command, right? And then based on this data, you are saying that the target is labels. That means in your input data, you have something called label, right? So you are telling the Redshift ML that train a model to find the customer churn, and this is your input training data, and the target feature is labels. Okay, so in regular machine learning, right, what happens is, let me just use my pen. If you can see, just let me know if you are. I'm not very sure if it will work or not, but I'll just give it a try. Okay, let me see if you can see. Okay, it's not working. All right, so let me just try it here. Give me a moment. Yeah, so let's say you have a data point let's say x1, okay, and x2 and x3, and then you have y, right? And these are in machine learning, what you do in supervised machine learning, what you do is, let's say these three are your features and this is your class label, right? And what you do is you train a model by giving all of these data, right? All this this is, let's say, data point 1. Similarly, you will have another data point 2. Similarly, you have another data point 3, and so on and so forth. right? But these are your features, right? X1, X2, and X3 are your feature, and Y is something that you need to predict, right? And when you give a input training data, you give this whole data set, and you say that this Y is the class label, right? Similarly here, if you now map this to this SQL query, this age, zip, then monthly spend, monthly cases, then activity, all are these, right? X1, X2, X3, but which is Y? Y is defined by this target. So here we have used labels, right, in the input, and we are telling Redshift ML that this label you should consider as your target. Okay, so that means Redshift ML will send this data to a SageMaker, and what internally Redshift will do is Redshift will copy the data to an S3 bucket, and then it will tell a SageMaker that this is the data, and I want you to train for customer churn, which is a binary classification, because customer churn means it can be for every customer it can be either yes or no, right? Either a person will leave Amazon.com website or it will continue using Amazon.com website, right? So it's a binary classification. So Redshift ML will tell SageMaker that with this data, just assume that label is the class. So that means you have to build a model which can predict labels. Okay, and then you have something called functions. Okay, so this is the function which will be your return value. Okay, so basically this is the function which Redshift ML allows you, which Redshift ML gives you, which you can use for later prediction. Okay, so now when you do the training, after the training is done, when it comes for prediction, again for prediction you have to give some input data, right? But in this case your input data will not contain this label thing, right? Because that is what you expect Redshift ML to predict, right? So that's why you will find that in the input data you will have age, zip code, and then there is I've just put break, but basically it will have monthly spend and monthly cases, but it will not have labels, because labels only it will predict, correct? So if you look at this SQL query, it is a simple select command, but the only difference is we are using a user defined function, or UDF, called predict customer churn. And what is this function? This is the function which Redshift ML will return while you start the training. Okay, so it's very simple. You push your data to Redshift ML first place. Okay, so assume that your Redshift, in your Redshift cluster, you have the data, and then all you have to do is you have to train using create model command, and you can specify, what type of model it should be. Here we have not mentioned any details about, which type of model, except the fact we are, explicitly saying it's a customer churn, which internally, Redshift will understand that this is a binary classification model that the user is asking for. You can check the documentation. We have some default algorithms, and now we also support custom models using SageMaker. But all you have to do is you have to run this create model command, and then you have to run select for prediction. You have to use a simple select command with this UDF. So what is this? This is a user defined function, right? UDF. This is the user defined function. And who has defined this function? You have defined this function while you are training it, right? And this is the same name, right? That's all you have to do. Okay, so now let's go to our demo, and then we will see how all of this works. So let me just exit out from here, and before we get into that, let me see if we have any questions. Yeah, sure. I'll give you the Joy. আমি এগুলো সব শেয়ার করে দেবো পরে, blog post वगैरह সব GitHub repo, everything I'll share. How do you, Abdullah, you are asking, have any idea of a visualization app or software like this Tableau? Yes, so we do have something called QuickSight, and I cannot show you today, but we can surely, yeah, I think Fasim has already replied, but we can have one demo with QuickSight as well, where we can show that after you do the prediction and all of this, right? You can put that through QuickSight, where you will get a lovely, dashboard where you can, which you can share it with your business users, right? And they can take some decision based on that, right? So that's the right answer. Thanks for responding. Okay, so let's go to our demo. Okay, so before we get into the demo, this is just for people who are new to Redshift. Okay, so a few terminologies before we start the demo. This blog has everything, but just for the sake of explanation, this is how a Redshift cluster looked like. Okay, so we are going to create one Redshift cluster. I'll walk you through how we create that. But basically, a Redshift cluster, as we discussed, that this is for data warehousing. That means there will be lots of data coming through, right? And it will be like mostly for analytics purpose, right? So when you create a Redshift cluster, you need to define something called leader node, which takes all the input request from your customer, from the client. And then yeah, is there any question? No? Okay. So we have something called a leader node.
I wanted to know something.
Yes, please.
As you said, this Redshift will itself a automated technique, like whatever the classifier we are using, you're saying that it will itself choose the best one. Like
Right.
in machine learning techniques, we actually try different types of classifiers and then check which one works best for it. So you're saying this is just an automated thing, and it will try every classifiers and
Right.
choose the best one. That means we do not need to know what is going in the background.
You do not have to know that, but we do support.
Okay.
But in the demo, we will see that how a data admin will use this feature, and how a data scientist will use that feature, and how a data, let's say a machine learning researcher will use that feature. So we have flexibility. If a machine learning engineer knows inside out about what algorithm to use and what should be the hyperparameters, he can always send that through the SQL query, and we will see that in the demo. So that's why a lot of things are dry. Once we go to the demo, it will be clear. Okay, we'll go to that. Okay, that's a good question. Okay, so this is nothing to do with the Redshift ML, but just to be on the same page. It has a leader node, and we have something called compute node. Okay, so if you don't define a leader node, it automatically picks one of the node as a leader node. Okay, and what happens is all the data request comes from your application to the leader node, and then leader node segregates a chunk of task to all these compute nodes. Okay, and all these compute nodes, you can think of it as a a system, a virtual machine with its own storage, with its own memory, a CPU, and everything. Okay, and if you want to go deep into this, you can refer to the Redshift documentation. But internally, within this compute node, we have something called node slice. As you can see here in the blue, it's very small, but I hope that you are able to see this. We have something called node slice, and each node slice contains a portion of memory and storage within that compute node. Okay, so let's say in this compute node we have, let's say, just hypothetically I'm saying, let's say we have 10 node slice. So 10 node slice will have equal amount of memory, equal amount of storage within that compute node. Okay, and who assigns tasks to all of these compute nodes? That's the job of a leader node. Okay, it's just like that. It's as simple as this. So let's go back. Just reducing the font. So this is how a Redshift cluster looks like. Okay, so the reason that I thought I should tell you this, because now we are going to log into the console and try to walk you through how we can create one. Okay, so let me log into the console. Okay, so once you are into this page, you can go to Redshift. Okay, and then if you are not, since I have some clusters created, that's why it is showing like this. Otherwise, you will get a welcome screen. Okay, so you will not get this page. Okay, so just like any other service, if you don't have if you have any resources created, you will directly come to the dashboard. So if you see here, if you click on clusters, you'll see that we already have two clusters. Okay, and this is a cluster that we are going to use. But I'll walk you through how, because creating a cluster takes some time. So I've created it beforehand. So let me click on create cluster, and we will walk you through how you can create a cluster. So you have to first give a cluster name, and then you have to give some node type. We have different types of nodes. One is compute intensive, and one is basically storage intensive. But these days, we do not recommend to use any of the storage intensive node like DC2 large or DC2 8x large, because these are this is how we started Redshift when we came up with this service. But now we recommend everyone to use RA3 types of instance, okay, or node type. So you can read about this, but you can get a summary of this. What it says, each node contains 128 terabyte of storage, and this is the pricing part, and it has 12 virtual CPUs. Okay, so you pick whatever node you want. For us, let's go with RA3, and then you can define how many nodes you want. You can have 2 nodes or 3 node or 4 node, or even you can start with 1 node. If you do with 1 node, then your leader node and the compute node, if you remember in this slide, we have this leader node and compute nodes, right? So obviously you might get a feeling that minimum number of nodes should be 2, right? Because one should be a leader and then one should be the compute. But that's not true. We can always have a cluster, with 1 node, but this is not supported for all the node types. But here, as you can see, we have to say at least 2. But there are different node types where you can have a single node cluster. Okay, so now if you scroll down, you have to give a database username, which is by default, it would be AWS user, and you can give your password. So let's say I give some password, and then you have to come to cluster permission. And here you have to define some role. Why we have to define some role for Redshift ML? The reason being is your Redshift ML or your Redshift cluster will need to copy the data from here to S3 before it starts the training. So that means it has to have the permission to read write data on S3, right? And not only that, it also need to talk to SageMaker, because SageMaker is going to train that model. So this is what that's why you have to create a IAM role for this, which I have already created. And you can just come here and select that node and associate that node. Okay, and then you have to come down and you can click on create cluster. So now this configuration will work fine for you because this feature is already in GA. But previously, when it was not in GA, we had to come down and come to maintenance, and we had to click on preview, and we had to select this SQL preview option. Okay, so this is just for your information. How when a service is in preview, there are some different thing from default which you have to do for most of the services. So, but now you don't have to do it because it's already GA. Okay, so one last thing that I want to show you is under networking, there is an option for public accessibility, which is by default disabled because you don't want your cluster to be accessed from outside, someone, right, or from any system. So you should always disable it. But for demo purpose, you may like to enable it so that you can take the endpoint of this cluster. Later on, I'll show you, and then you can connect through some SQL connector. Okay, and for for this demo, I'm going to use this tool called Data Grip, but you can use any connector for that matter. But if you want this any external connector to connect to your cluster, there are two ways that you can do so. Either you enable, which is not a recommended practice because you are just opening the cluster to the whole world. But other way should be, which is ideal one, is you have to disable it, but you can use some, some Bastion host or something, right, where it will use an SSH tunnel to access. So your tool, like let's say this is a tool I'm going to use to run SQL query, Data Grip. So Data Grip will talk to that S3 to that EC2 instance, and from that EC2 instance, it will get connected to this cluster. Okay, so that is a best way to connect. So then you have to just click on create cluster. I'm not going to do that. That's why I'm just canceling it. And once it is done, you will see the cluster here. And then you can click on this cluster and you have to now connect to that cluster, right? So you can copy this JDBC URL. Okay, this is the connector. And if you now go back to this image, you see this ODBC or JDBC connectors for your application. So similarly, we can use any of this endpoint depending on from where you want to connect. Okay, so you can click on this JDBC connector and you can use any tool of your choice. I'm going to use Data Grip, but you can use anything. That's a very nice tool. If you use Python, you must have used PyCharm, right? So this is from the same company. Okay, that's a wonderful tool. So all you have to do is you have to come to this plus button and then click on data source and select Amazon Redshift. It has a plugin for Amazon Redshift. And the moment you click on this, you can give all the cluster details. So here you have to give the JDBC link, and you have to give the username, and you have to give the database name and the password which you have set. And that's all, right? And this is the port. By default, this is the port, and you will get connected. And in case you have disabled public access in the networking site, which we have seen, and you are planning to connect to this through some Bastion host or any EC2 instance, then you have to come to SSH and use this option, and you have to give the details about your EC2 instance. Okay, that's how you can connect. And then you just have to click on test connection. So I have already connected this cluster. Okay, and now we are going to walk through the whole process of creating model and all of this. So since it will take some time to create a model, that's why I've already created, because creating a model takes some time, as you know, but we will walk you through, how we can do so. Before that, I see there are some questions. So let me just, okay, all our email IDs. Okay, that's fine. So now the first thing that we need to do is, the data that, so let's first talk about what type of data that we are looking now. Okay, so here we are going to look for a bank marketing data. Okay, this is a free data, so data set which we have, in the, it's there in the Kaggle website as well. Okay, and we have to predict whether a particular client, okay, will have a bank deposit or not. Okay, so whether a person will go with a deposit, a long-term bank deposit or not. So it would be a yes/no kind of a problem, right? Again, a binary classification problem, just how what we have just discussed in the presentations. So we have to just build a model or train a model which can do this yes/no kind of prediction. Okay, so if the client, so here what it says, the classification goal is to predict if the client will subscribe to a term deposit or not. Okay, so this is what the problem is. So let's first, what we have to do, we have to create a schema first, right? Because the data warehouse, it's we have to first create a schema. So we can give some schema name, and we can run this. I've already executed that. That's why I'm not running it. But the way to run it is, if you're new to this tool, you just have to select this line and click on this play button. That's all. Okay, and then you have to first then create the table, right? So now your table is going to have the same schema of your data. So my data is coming from an S3 bucket. So actually my data is there in this CSV file, which I've saved in S3 bucket. And the way that you can load data from S3 is using this copy command. Okay, so now I already know this data. Okay, I have opened this CSV file, and based on those columns, I have created this table. It should match exactly. So that whatever are the column names, it should come here in the table name. Okay, all these features basically. So you have features like age, job, marital status, education, and so on and so forth. Okay, and then there is a feature called, or the class, this is our class level called Y. So this should be the feature which this should be the class level which we want to predict. Okay, so now since in machine learning we always have two data sets, right? One for training, one for testing or inference. So that's why we are creating a table for training. And now we have to load the data. And how we are loading the data? We are just saying demo_ml, which is the schema that we have created. And this is the table name, right? This whole thing is the table name. So we are saying that copy to this table from this S3 bucket location, whatever is the file name. And we have to specify the IAM role. So this is the same IAM role which we use to create a cluster. Okay, that's all. Now, once this copy, and then you have to give some delimiter, like, how your data is saved in the CSV file. Now, once this is done, your Redshift cluster will contain all the data. So now you don't have to worry about S3. You can forget about this. Your data is now loaded in your Redshift cluster. Now, similarly, for inference also, you have to first create a table, right? Same way we are creating a table, but this time we are giving a different name, table name. Client details for inference. Okay, this was the table name for client details, and this is just underscore inference is just appended. Okay, just to differentiate. And again, you have to load the data for training. For inference. This should not be training; it should be for inference. Okay, and you again have to specify the file name in the S3 bucket, and again the IAM role. Very simple thing. So once this is done, then comes the actual fun part. So ideally, in your company, most of the time, see whatever we are going to see now till this point, right? These all are optional, but this is how you will be using in practice, right? Imagine that you are a company, so you will have some database admin or database developer who will have access to only select command or only describe command, or maybe insert commands, and so on and so forth, right? And you might have a data science group who knows better about machine learning and things around that, right? So if you don't have, then you can just go with only one group where you will have all the database administrator or database developers. But here, we just to showcase that you have a fine-grained control over the users as well to run the command, we are creating two groups. Okay, one group name is a database development or DB dev group, and another group is data science group or data science underscore group, as you can see here. And within these two groups, we have two users. We are creating two users. One is DB dev user, and another is data science user. And why we are doing this? We are doing this because we want the training job to be started by someone from this data science group. Okay, if your company has that, if your company doesn't have, that's completely fine. You can just ignore this. But in a real world, you might have someone who is more specialized in a data analyst or a data science side. So you may create a special user for him or her, and he or she will be responsible to run that SQL command to create a model. Okay, that's what we are doing in this 4 lines: creating a group, creating a user, again creating a group, and creating a user. Now, next thing is you have to grant access, because you have just created the user and groups, but you have to grant access, and that is what we are doing here. We are giving different types of, granting different types of access for different types of groups. Like for data science group, we are granting create, usage on, schema access. Similarly, we are also giving all access to all the tables. Similarly, we are giving all access to all the tables to the dev group as well. But see this, we are giving create model only to data science group. We are not giving this access to create a model for anyone in the database group. Okay, so that means if this user, db dev user, tries to run this command create model, it will fail. Okay, so this is about just the till this point, it is just about the access control grouping and all of that. You can just ignore that if you don't want to do that. Okay, so now comes the fun part, right? We have to start the training. So how we can do so? So since we are training it, we have to make sure that we log in through or authorize a data science user from the data science group. And that is what we are doing, right? Set session authorization data science user. Okay, and then we are just, this line of code is just for me basically, because I was just playing around this. So if any model exists, we are just discarding that. Okay, if there is any model exists of this name, because this is the same name we are going to use while we create a model. Okay, so you can ignore this line. This is just for demo purpose. I have written this so that it doesn't give me an error when I try to create another model with the same name. Now this is the training create model command. So let's walk through this command. So we are giving create model and then the function name. Okay, so this is dl demo underscore ml dot function model bank marketing. Okay, this is the function name. Okay, and this is the function name which we are going to use for prediction as well later on. Now, for training, we know that we have to give some input data, and how we give the input data, we have to give the input data using a select command. That is what we have seen in the presentation, right? And the select command, we are saying all these fields, age, job, education, default, all of that. And from where? From demo underscore ml dot client details. And what is this client details? If you remember, demo underscore ml dot client details, this is the same table which we have created here, right, in the beginning, and where we have copied all the data from S3, right? So this is the same table we are passing. So let's go back to this command. So this whole part, right, this is our input data. Right now, we have given the input data. The next thing that we have to tell Redshift is what should be the target feature. So out of this, which feature should I consider as the target? So that's why you have to mention target space whatever is the feature name. So if the feature name was, let's say, loans, I would have written loans here. Okay, but for this problem, I know that the class label is Y, and it's a very weird name, but this can be yes or no. Right, as we have seen. So we are giving this target target label, and then we have to give the function name. So this function name is exactly same as this name, right? This is just the same thing. And then we have to give the IAM role. This is the same IAM role that we have created while creating a cluster. This is the same IAM role which we have used to copy the data from S3 to Redshift cluster. So it is the same IAM role. You have to give that. And then you have to give some configuration details. You have to give the S3 bucket name. So this is the bucket name where all the data will be stored after the training of the model is over, right? So because once the training gets over, it will have some data, right? So that data will be stored in this particular bucket. You have to mention that. And then you can give some default runtime. So here, I guess this is in minutes. So, no, not in minutes, sorry. It's in, I guess it's in second. Yeah, this is in second. By default, it is 90 minutes. And I've given, I guess, 30 minutes here. Okay, but what this means is it will just stop the training once it reaches this time period. Okay, because at the back end, SageMaker will start the training and it will use multiple models, right? So how it would know that how long it will continue, you can control using this max runtime option. If you don't give this, by default, it will run for 30 minutes. I'm not very sure after GA if they have changed anything. You can check the documentation, but basically this is one way where you can control the training time. So once this is done, and this command is completely asynchronous. Okay, this is very important to know. This is a completely async command. What that means is you will get the response immediately, but that doesn't mean the training is completed within that a few seconds, right? So you have to check the status by running this command. So let's run this command and see the output. It's running now. So let's give it a moment. So if you see, I have 2 or 3 demos. That's why it is showing 3 different schemas. But this is the model that we have, right? Func underscore model underscore bank marketing, and it says it's active, and it says model is ready. But when you do it for the first time, right, while you are training, you will see that here in that command, in the model state, it will say that training is in progress. So you have to wait till it says model is ready. Okay, so that is something that you should run when after you create this create model command. Okay, so it is asynchronous. Always remember that. So you have to keep on checking the status, and once the status says model is ready, then you can do some inference. All right. So now that your model is ready, what you have to do is you can show the details about, you can see the details about that model by running show model and then the function name, right? Which is nothing but demo.ml dot function model bank marketing. So let's run this. And you will see that all the details about that model, and this is coming from, this is all coming from SageMaker. So it says what is the model name, who is the owner, see the owner who has executed this command, the state of the model. Then you will see what are the parameters, that it was used while training. And it also tells you the target column. It will tell you what type of problem it is. This is a binary classification. That's why it is binary classification. You have this objective function. It can be accuracy, it can be F1 score, it can be ROC. There are a lot of different objective functions out there, right? So you can check the documentation and you can pick that. Here we have not mentioned any of this. That's why it has picked up F1 for this binary classification problem, but you can always define that. Okay, so that's about it. And once this is done, now the last part is the inference. Right. So now the model is ready. Now all you have to do is you have to see, how good is your model, right? You have to know how nicely you have trained your model. So for that, you have to find the accuracy, right? And how you will do that? You remember that we already had the inference data, right? If we scroll up, you remember that we created this a table which contains the data for inference. Right, and the name is client details inference. So we are going to use this data, okay, whatever data we have in this table. So now if I scroll down, now how you do that inference, you say with inference data as, so this is the data, right? If you know SQL, this is the data that we are parsing as, and we are calling this as an inference data. Okay, and how you are there is a subquery within this. We are saying select y as actual. Okay, why as actual? Because y is the class table, right? We don't want y to be sent to the model, because that is what we want to check, right? And how we are doing this, we are saying keep y as your actual, because we are going to check this with the predicted value, right? That is what we do in machine learning. We send the data and we take the prediction, and then we compare that prediction with the actual class level, right? And that is what we are doing here, okay? Where we are checking actual is equal to predicted or not. Now, actual is y, we have mentioned this, but what is predicted? Predicted is this one, right? So if I just scroll down a little bit here, see, this is the predicted one. Okay, so this window is a little small. So this is the predicted one. And how we are calling this, how we are doing this inference, we are using the same user-defined function, right? demo underscore ML dot function model bank marketing. And then we are giving all the features except Y, right? Because Y is part of actual. So you will not find Y here. See this? We don't have Y here, right? So, and we are saving this as predicted. Okay. And this is because these all are select command from where? From demo dot underscore ML dot client details inference. Okay, and here we are just doing a small if else checking because we want to calculate the number of correct predictions. So that is what we are checking here, and we are just saving the number of correct predictions and the wrong predictions. And why we are doing so? Because we want to calculate accuracy. Okay, and how we are calculating the accuracy? By total number of correct predictions divided by the total prediction. Okay, and if I run this, so let's run this, and then we will see this in the output. So you see this, the accuracy is roughly around 89%, which is not all that good, but that's okay. We have not sent any hyperparameters, nothing, right? All we have done is we have just sent that data, and we forced SageMaker, Redshift ML, to talk to SageMaker, and SageMaker will do an auto ML, and it will just do based on the information that you have given, right? So that's how you will do the accuracy test. And then if you have to do a prediction, same way you have to do that, exactly same way. You can just send the data with the select command and all of that as I predicted, right? And you can define the from table. And then here we are just having a switch case where we will just print it in a nice way, not as yes or no. If it is yes, then you will say that yes, we will do a term deposit. No means no term deposit. Okay, so and then we will group by this. Okay, so let's run this and see how it looks like. So here it says yes, we'll do a term deposit. That means this is the probability of yes, which is around 797. Okay, so now if you look at this, we have not done anything specific to machine learning. You don't need a data scientist to do this, right? All of this is done by a Redshift ML by this single command, right? By this single create model command, right? And a lot of things that in the background it has done. It has copied the data from Redshift cluster to S3, and then it has trained a model on SageMaker using that data in S3. And SageMaker has used AutoML, and it has used lots of models, created lots of models, and then it has given the best model, and it has saved that whole model as a function, which is a user-defined function called func_model_bank marketing. And this is what we can use, and we have used for prediction or accuracy test or anything of that sort, right? And now you can give this data, to your higher ups to take some business decisions, right? Like maybe you can send an offer to people whom you have predicted as are predicted no term deposit, right? So you may send a marketing email to them and all of this, right? So you can always print the details of who are these users, right? Because you have the data in your Redshift cluster. And similarly, as someone mentioned, you can also project this data back to QuickSight for a proper dashboard. Okay, so that's about this. So now I'll just, we already have time, but I'll just quickly walk you through the next demo. And in the next demo, assume that the first demo is run by a database admin who doesn't have that machine learning knowledge. And that's why in the create a model command, you don't see any specific parameter around machine learning, right? Now let's go back to another demo. And now this demo is, you assume that this is run by some data scientist, okay, who has some machine learning understanding, and he can define what type of model or algorithm to use. Now, this data for this problem, we are using a data set from UCI called steel plant faults. So basically, this is also a classification problem, but it is not a binary classification problem. It is a multi-class classification problem. So because the output class label are nothing but different types of faults a steel plant can have, okay, on their products. So there are different, I guess there are 7 types of faults. So here they actually have 7 different types of fault. Okay, so the expectation is from the Redshift ML is it should be able to predict this, different 7 types of faults. So again, this all part are very common. You have to build create a schema, then you have to create a training table, then you have to put the data, like feed the data from S3. And again, all these parameters, how do I know about all these parameters? I went through this website and I noted down what type of data that is, what are the features that it has and everything. So I just copied from here, okay? And the same data is there in the same format in this steel fault trained CSV, okay? And similarly for inference also, we have to create a table and we have to copy the data from S3 to this Redshift cluster. Once that is done, this is again, if you want to drop a model, you can drop it like this if you want to play around. But this comes, here comes the fun part, right? So here I have not used this different users or groups because I just wanted to show you there so that you don't have to, you don't have to repeat that everywhere, right? But just to give you an intuition that there is a way to restrict control over running different types of command on Redshift cluster. So here, while you create create model command, you will see some difference. So let's see what is the difference. So here we are saying create model and then the function name, which we know that we have to specify. And then the from statement should contain all the input data, which is nothing but all the features that we had, right? And this is from the table name, right? And again, we have to define the target label or the class label. And in this case, it is steel type. And that's why the target is steel type. And then we are giving the function name, and the function name is exactly same as what we have given here, func model steel fault, and we are giving the IAM role. Till this part, everything is same, right? Now comes the fun part. So here you are defining a lot of things. Now here you are defining the model type, problem type is multi-class classification. And you want to use an objective function of accuracy. If you remember, last time it was F1 score, because you have not mentioned anything. SageMaker has predicted whatever is the best F1, whatever is the best objective function for this problem, and it has identified that as F1 score. But here you are explicitly mentioning that you want accuracy. Okay, and then you are defining again the S3 bucket name where you want to save your data after the training is complete, and what is the max time. Okay, and again you can check the status with this command. We have seen this, and then comes the inference part, right? So this part is almost similar to other one. It's just like the way that we have counted is little different because the data is different. So let's run this to check the accuracy. And if you see, you will find the accuracy here. It's the output of the last comment. Yeah. So if you see that accuracy is roughly around 80%. Okay. And sorry. So now the last thing is let's do a prediction, right? And here we are predicting for the whole data that we have in the test data. Okay. If you scroll here, extreme right. Oh, sorry, here only. So if you see the from statement, it is from the steel plant fault inference, okay, which is the second table that we have created, right? So let's go ahead and run it. And you will see the output of all the data points. If you see, there's lots of data points, right? So it is predicting for each and every data point what type of fault it is. Okay, so since this is not a binary classification like yes, no, and 0, 1 type of thing, it can be one of the 7 different types, and that's what it is predicting here. Okay, so this is about any data scientist if he runs a model. So you see that there is some level of flexibility. I guess you have also asked, right, how you can define the objective function and type of problem and so on and so forth, right? But still, let's say a different type of user you have in your company who is more advanced, who knows exactly what type of algorithm to use and different hyperparameters and all of that. For them, you can even give some more information, and that's what the last demo is. So the last demo is again for a different data set. And let's forget about data set, okay, what that data set is. But this is actually, this is not a classification problem. This is a regression problem where we want to, calculate the height of abnormal, the species. So this is a different data set that we have in the UCI repository. So, but this is a regression problem. Okay, it's not a classification problem. It's a regression problem. So similarly, we're creating tables. This is a boring stuff now. By now, you understand that what is the flow. You create table, load the data, and then create the model. So here you see that there are a lot of different things that we have mentioned here. Right. First thing you would notice that I hope that till this part it's all clear, right? You give a function name, right, and then you give all the input data, and then you define the target. You define the function name, which is exactly the same as this, right? And then what you do is you are saying auto off. That means you are telling Redshift ML that please do not tell SageMaker to do anything of his own. Okay, I am going to tell you what you should tell to SageMaker. Okay, that is how you should think about it. So you are saying the model type should be XGBoost, right? Which is one of the famous algorithm that we have which is based on decision trees, right? So, and XGBoost can be used for regression problem as well as for classification problem. So we are telling Redshift ML to use XGBoost and to use an objective function of not accuracy or not F1 score, but root square root error. Okay, so RMSE basically, right? So we are mentioning the objective function, which is square root error. And we are also saying there is no pre-processing needed. So here we are saying none, but we support a lot of different pre-processing. So right, what are different types of pre-processings? Like one of the pre-processing might be a PCA. One of the pre-processing might be, let's say, one-hot encoding, right? So there are a lot of different pre-processings available. You can make use of that. Okay. And in fact, let me quickly show you this because I wanted to show you that pre-processing. Yeah, see this is a this is a help guide for developer guide for create model command, right? And if you scroll down, you'll see pre-processors, and it can have many things like PCA, then one-hot encoding, then there are different imputers available, and so on and so forth. Even you can normalize the data as well. So these are very much data science related or machine learning related, right? So you can always define all the pre-processors here. You can also define hyperparameters, like how many times you want to run, and depending on what type of algorithm you are using, the hyperparameter would be different. You can check the documentation of XGBoost in Redshift ML, and what are the hyperparameters are available. You can mention that here. Okay, and then again the settings where you define the S3 bucket. Right, that's all. And similarly, I don't want to blabber around that again, but again you can just run the accuracy. Like let's first execute this, and you will see that this time we are getting an RMSE score, right? And if you want to do the prediction, let's run this. And you will see that the age group between 10 to 20 is this much, 5 to 10 is this much, under 5 is this, and over 20 is this. And how this grouping is happening, because I am doing that grouping in this case switches, all right? Because I'm just reading the data, and we are saving the prediction in ages, right? In the variable called ages, or the parameter as age. And then we are just checking the value of age and tagging it in a different bucket or groups. Okay, so that's about it. So I hope you got some intuition. I know that we have not covered all the nitty-gritty about all the different algorithms, but I just want to give you some intuition. And for more details, what you can do is you can read through this part 1, and this part 1 contains all the details about how you can connect to a Redshift cluster, like how to create a Redshift cluster, and also it will show you how to, just let me scroll down. how to create a cluster. The only thing is when you do this, if you are following this blog, you don't have to enable this preview settings, okay? Because preview settings are no longer valid because it's a GA feature, and this public access, you have to make sure that you select yes for demo purpose, it's okay. But if you're doing it for your production or something like that, you should select no and use SSH tunnel for that. SSH tunneling, I have not shown it here. If you want to play around that and if you need help, I can help you with that as well. If you can just ping me. But basically, after that, you can connect to how you can connect. I've shown everything here. And finally, you will go over all the demo that we have shown. So this part 1 contains the demo that we have shown at the beginning using the bank marketing data. And then if you go to the second part, the second part is we have 2 demos. One is from the data analyst perspective, which is the second demo, and the third one. And I've mentioned, what are the different problem statements that we support till today: binary classification, regression, multi-class classification, and so on, right? So you will get a little bit more details. And the last demo is from data scientist perspective, because we are actually, giving the inputs like what type of model to use, like XGBoost or whatever, right? So that's about it. So you can follow these 2 blogs. Let me just share you. I guess if I give you the one blog link, the second blog, you will automatically get it. Okay, I guess you have already shared. All right. Yeah, so this is the, and you also have the GitHub repo. Okay, and if you go to the GitHub repo, what you will get is, you will get, if you click on this demo, you will get all this SQL statements. Okay, whatever I was running, it's all maintained, saved here, so you can go through that as well. And there is a dataset part which contains all the dataset. Although I would recommend you to pick that up from the Kaggle, but these are the 3. We have 3 demos, and each demo have a training dataset and an inference dataset. So these 2 are like total 6 files, okay, for different types of problems. So that's all that I have. So if you have any questions, you can, ping me, or you can tell me now as well, or whenever you play around, just, ping me anywhere, like on Slack or LinkedIn, wherever you feel like. Okay, so that's all from my side.
Sir, is it possible to program Redshift to stream the real-time analysis and ML results to some deployment site or websites?
So can you just, so the question is, let me understand your question correctly. So your question is, your streaming data will come to Redshift cluster, and then you have to use that data to create a model. Is that the understanding correct?
Yes, and the results will be delivered on real time on some app or website.
Yeah, got it. Yeah, sure, you can do that. So in fact, we do have something called data lake, or lake formation, and there you can actually have data coming from Kinesis, and which is a streaming service, and it can throw the data to Redshift cluster, and then Redshift cluster can run this ML query, and that once you have that ML query executed, right, you will have the predictions, just like here, right? Let me open this. If you go to let's say this demo, right? So if you run this prediction, because why I'm running this, because here I'm not putting any filter, right? It's just the inference data, and I'm giving the table name. And if you see, this is the output, and you want this output to go in real time, right? Yeah. Then now that you have the data, you can put it anywhere. You can send it to some other database. You can actually even trigger a Lambda function, which will go to your application. You can do whatever you want.
Thank you.
Okay, good question. Yeah.
Okay. May I ask, I am new in AWS, so may I ask a silly question? Why need Redshift? Actually, I didn't understand the basic thing.
Yeah, sure. Sure.
Why did need the Redshift? Why need Redshift?
Absolutely. Yeah.
Okay.
So yeah, first of all, there is no question as silly question or small question. Okay, so I mean, you should never shy away from asking question. It's not about me, but anywhere you go. Okay, so that's a very good question. Why we need Redshift in the first place, right? So the reason that why we need Redshift is not for regular database. Okay, like if you want to have a transactional workload, like let's say you go to bank, you go to an ATM where you do some transaction, you will not use Redshift in the backend for that kind of workload. Okay, Redshift will work very pathetically. In that case, you will use some RDBMS or any relational database, right? Like MySQL, Aurora, RDS, and so on and so forth, right? Even you can use DynamoDB for that matter, which is our NoSQL database. But if you want to do some analytics on your data, right? So when I say analytics, most of the time these data are written at very large, large quantity. Like let's say we have this this company, like let's say Amazon.com. Okay, so let's say this is our website, Amazon.com. So now if you think about it, all the data that we have here, so let's say if I click on my orders, or if I click on any of this, let's say any item, right? This data is not coming from Redshift, right? So this data is coming from some database, okay, in the backend. But whatever I am purchasing, right? If I go to my order history, and if you see, all the purchase for last 10 years, right? This data need not to be in some database, right? It can stay in a in a Redshift cluster. Why we can save this in a Redshift cluster? Because using my my pattern of buying, Amazon can send me some promotional emails, right? And for that, Amazon will not run a query on a production database, right? Because it will slow down the production itself, because Amazon is trying to understand what is the behavior of their customers, so that they can take some decision. Okay, it might be dropping some product from their product line. It might be sending some promotional email to the right set of people, and so on and so forth. But basically, the idea is Redshift is used for data warehousing. Okay, so there is a fundamental difference between database and data warehousing. Data warehousing is used for OLAP kind of application. You can just search OLAP and OLTP. Okay, so OLTP stands for small transactions, and OLAP is for analytics processing, which means you have a data, you have to make sense out of the data, and basically you have to analyze the data and come up with some idea or some information which can help me to drive a business.
Okay, is like that old data for the processing, like customers, or
yeah, you can say
like that. Okay.
Yeah, in this example, that is what we were referring to. But there can be multiple references. But yeah, in this context, yes.
Okay. Another thing is you have shown me the function, that is user-defined function or built-in function.
Yes, this one, right?
Yes, is for
So this is why we say this is user-defined function, because this function, when you create a model, before you create a model, there is nothing called function underscore ML model underscore steal fault, right? There's nothing like that in the SQL query itself, right? You are defining this function, right? And that's why we call it as a user-defined function.
You have made this just demo data, like this column select this that from table. Is it demo table or like that? Or
oh, okay, this one.
Yes.
Okay, got it.
Column like, is it a demo?
Why it is like this, right? Even if you don't.
No. I'm asking the select table name from the column name. This is this demo.
Yes, from where this is coming, we are giving this, right? From where it should come. These are the select command, right?
Yes.
So if you don't give any of this, you can just give star as well, because we are selecting all the columns.
All the work, yes.
Yes, because here is the from.
Okay, and the create model, it is like we have seen, we have learned or it code in MBSC pattern. Is that like that? The model is like that for database, the where the query or all the things have in the model. Is it like that model? Why need model?
Okay, this create model command.
Yes.
Okay, so this is a new, so this was not there before. This was introduced after we released this Redshift ML. This will not work in any data warehouse. If you use any other product, this is not a regular semantic of SQL, right? This is the semantics to create a model, right? And we have defined this, so you cannot use something else. This is the command, just like how you run this command, right? Show model all. So this is also related to models. But let's say let's pick some regular command of SQL. Like this is a regular command from SQL, right? Create table.
Yes, it is a regular command. And
right. So this is not a regular command. And why this is a custom command? Because this is a custom feature. You don't find machine learning in all the data warehouse that we have in publicly available with different vendors, right? So this is our implementation.
Okay. Okay, thank you.
Okay, sure. Thanks. Great questions.
I have a question in liaison with the sister Sumaya. That is, she asked in software engineering. Should I continue?
Yeah, please.
She asked regarding the question of model, the keyword model. That is, in ASP.NET or some other languages, we use model view controller strategy for coding.
No, I am not a ASP developer. I am a PHP developer and Java.
Yeah,
so
yes.
I don't know
There is a model view controller thing.
Yes, yes, the MVC pattern. I am asking that.
Yes, that is what I am trying to go to in conjunction with Suman. That is the model keyword used in the query here is machine learning model, not model
right.
view controller, that type of thing.
Okay.
Absolutely.
For the machine learning
yes.
keyword. Okay.
Yes. Right. Thanks for clarifying. Yes. Okay, great. So that's good. A lot of questions. I just love it. So that means you are listening. So otherwise, I feel like, because I was going through my own slide, I was feeling like, to sleep off. So that's good.
Previous lecture, I lost attention, but thank you for this lesson. I don't know why my attentive here is work here. So
absolutely
I can
সবসময় জিজ্ঞাসা করবে এরকম কোনো ব্যাপারই না কোয়েশ্চেন আনসার হলে কি শুধু কোয়েশ্চেন আনসারই হওয়া উচিত অ্যাকচুয়ালি রাইট এখন সন্ধ্যা হয়ে গেছে এখন কারো সবাই কাজ করে এখন জাস্ট want to take rest, right? So no one is interested for any demo. You can always go over the blog or any good document and you can just do this, right? So we should spend time on question answer. That only makes sense, right? So I'm also learning from a lot of you, like how things work in ASP.NET. I'm not an ASP developer, but good learning for me as well.
Thank you.
Thank you so much. All right. So that's all from my side. Okay, so if there is no other questions, then maybe we can call it a day. And thank you so much for joining the session. And feel free to ask me questions, whenever you feel like. Yeah.
Hey, I was gonna ask everybody before you finish up to take a quick picture. Can you guys come in the video, please, if you don't mind? Everybody come in video. Because I want you to do start writing. Amazon is all about writing culture. Suman knows about it, narrative and stuff. You got to be writing a LinkedIn entry, what you did and something like, yep, come in videos. Everybody come in videos. I'm just going to take a quick picture. It's going to be 1 minute. And you guys should take a picture as well. Come on, come on, come on, come on. Anybody else? Come in. Thank you. Thanks for coming to the picture. I'll take the picture. I'll give it back to Suman. Hey. If you want, you guys can take pictures. You can stay in video. And Shuman, I'll return back to you.
Sure. Thank you so much. Thanks for your time. So I want to give away something. So we have, how many people we have? I guess we have roughly around 15, 16 people, right? So maybe 13 people. So I want to give you some credits of AWS credits. So we have some credits. So how I can distribute that? Can I send it over email or something? Zaman bhai, if you...
of that, sir.
Yeah. Okay, I can send you. Okay, so can you do me a favor? So whoever are now in this list, can you just ping me on Slack if you are into the Slack group? Okay, or I guess Zaman bhai might have the email ID as well. I'll send it across. Okay, so maybe by tomorrow I'll send it across. Or you can type it here also now before quitting. I'll just copy it all. I think that would be easy, right?
I think it will be better if you can give the credit to the to our machine learning group.
Yeah, but I don't have that many number of credits. I just have 15, 20 credits, which I can give it to this set of folks, because you have been here.
Email address has already been given to Jaman sir.
Oh, okay, excellent. Then that's fine. Perfect. Then I'll send it across. Okay, cool. Thank you. Thank you so much. Thanks for your time. Yeah, have a good night.
Thank you very much.
Thank
Bye.
you too.
Take care. Yeah.
Bye.
Thank you so much.
Thank you. Thanks. Bye.